to walking down the aisle, right? My parents are proud. They're like, oh my God, you finally graduated, you know? And they say I can't walk with my class because I need 60 credits from Penn State. So I had to take one more course. I took it from my local campus in Allentown. It was the eco course. During the course, I'm just like going through the paces, and I'm like, can't wait to get my degree. But there was one trend. Has anybody heard of the graying of America? Does anybody know what the graying of America is?
Everything's gray, no architectural appeal.
No. 20 push-ups. No, the graying of America is basically the baby boomers getting old. So it's a trend that I actually had a few girlfriends and their parents were rich from it. And I started thinking, man, I wish I would have been paying better attention. I think I got a B on that quiz, you know? So I started like keeping my eye out for these trends. And early in my career, after I graduated from Penn State, I got into bridge inspections. And next thing you know, I mean, I just couldn't believe what I was seeing. You know, I shut down one bridge, and others were just exactly what my predecessor was showing. It was just completely, you know, putting your fist through stuff. So I dubbed the phrase the rusting of America. And I started recognizing this trend. And I kind of like just started thinking, okay, you know what? They got rich with the graying of America. I'm gonna kind of keep this here on the frontal lobes and kind of gear my entrepreneurial spirit in that direction. And that's what I've done. And this actually is a combination of that and my military background as far as keep it simple, stupid. That's a phrase we use in the military. And us engineers tend to overcomplicate things. Where, you know, keep it simple, stupid. If you keep that right here in the frontal lobe also, you can really find, you know, less parts and pieces usually make the better outcome. So, you know, considering what we're experiencing right now with the infrastructure, we know it's in a dire state. And, you know, ASC is trending it down. The infrastructure is rated. When you look around the world, I'm surprised we even have a C-, to be honest with you. But, you know, the infrastructure bill is imminent. The money's about ready to hit the streets. I think we're going to start rebuilding the U.S. infrastructure in these over the next 10 years. I think we're going to have a much better report card. But one of the areas that, you know, I found throughout 20 years in New York City, PMing jobs. You know, I was with PB and I got pulled away from a headhunter for twice my salary to go to the construction site again. You know, started on the construction side, ended up back on the construction side. Money dictated, right? I had a couple kids, you know, not your typical student or engineer, nothing in my life's typical. Anyway, these bridge brackets, every job I got on, I had issues with these bridge brackets. Well, I got to commute 2 hours in, sometimes 3 hours home, a lot of time to brainstorm. And these are one area I started looking at being like an area that could get improvement. And if you start thinking, during my military, I was in Lebanon for 6 months. I saw these aqueducts built before Christ, and I saw the overhangs there, and I reflected back, I'm like, they're still building overhangs the same way they did before Christ. I mean, come on, there's gotta be a better way. You know, they've improved the interior with the SIP forms and stuff, so why can't we do it out here? So that's where, you know, the juices started cranking, and I really started thinking about it. And, you know, everything's below, so it's really antiquated, and it's very time consuming, and it's very dangerous actually, because I don't know how many times I've came in and the winds have blown. It's basically a kite. Until you get any concrete on it, this thing's very prone to uplift. And I've experienced, and most contractors have experienced, and I'm sure some engineers have heard about it, but it's really not a very safe or fast way of doing this type of construction. Here's one of the pitfalls that Texas DOT found. Because of their bolt teeth and their flanges, so on top of all the obvious stuff, there's stuff that's not really intuitive, but this shear failure here is basically just a point load on the edge of a thin flange, and it doesn't matter how far back they put it, you're still gonna, that little rod's gonna bend, and you're still gonna get that force, and it's still gonna break. So I think they've gone a couple of different routes to try to fix it. One way was to put a conduit and bring that through the flange, which precasters hate, because now they got to go inside the form So, you know, it adds cost, time, it's not serendipitous by a long shot. And they kind of, you know, the Texas University comes up with a study and they kind of talk about, oh, but they're thinking inside the box too much because they're talking about how they can create a better hanger system. They just throw the hangers away. Get outside of the box, start looking around, open that, don't open it up just 180. Let's go 360 and really start looking at, you know, how can we solve these problems that we have out there and keep it simple. And that's what I did with this panel. It's basically just an L-shaped panel. There's nothing to it, that's precast. Started out 2.5, we're now at 3 inches because we followed, when we did this project at LaGuardia, they wanted guidelines and specs to follow. And I'm like, nobody does this. You know, I'm going to ACI, PCI. Nobody has anything on it. I don't really have any foundation, but I found something with the Architectural Precast Institute. They have a bunch of good guidelines and they give you, you know, standards to follow. And they have like, you know, with the certain ratios to keep. So we increased it to 3 inches just so that we could kind of stay within their guidelines. And be a little conservative considering the innovation and the you know, it's very new. So we want to make sure we're always erring on the side of caution, so to speak. But I'm going to break this down in a couple pieces in the next couple slides. But right here, I just wanted to show you, you know, this is basically the panel, right? And this notch is just locked into, or not even locked, it just sets into the edge of any 90-degree outside flange, whether it's precast box, old T, steel, it doesn't matter. And you know, Newton says that these forces are going to be pointing in and down. That's your resultant forces coming off this because of this tie. That's the load path that's coming through here, down, in. So this secondary tie is just that, it's belts and suspenders. It's not really needed, what it's there for is we don't want this guy to bring in a piece of rebar and bump it and knock it off its shelf. So the key is that that's only there for redundant systems. The other thing is, like this has been vetted through New York State DOT. New York State DOT wanted redundant in the system. And I said, there is redundancy. Yeah, but you only have 2 ties. What if we take 1 tie off? It doesn't go anywhere, it's redundant. It only needs 1 tie. Even in a centric, you can stay up with 1 tie. When we did testing, we have a whole test series at Lehigh University, Atlas Labs. So, you know, this has been in development for 10 years. The patent's 10 years old. We got 10 years to go. And, you know, this was the LaGuardia Airport. It was gonna go into the Delta Airport, but the doggone pandemic got in the way and it lost a lot of its momentum. So I'm here to kind of revitalize it because it's a keep it simple, stupid idea that we really need to kind of get out there and get the contractors. And with the design build environment, you know, there's a lot more collaboration, and I'm hoping you engineers can bring it to the contractors because you'll be the shining star that will be like, wait a second, you're telling us a better way to build? That's what we do. You know, you design. Share this with your contractors and all your design build contractors. I guarantee you, they'll like you for it. So one thing is we're working with we have a partner in ShoreBuilt. They're out of Chicago, and they're helping us with all our development of the hardware. And this project really, you know, we really had, you know, a ton of lessons learned from the beginning to end. But there was 1,800 linear feet. That's 9 spans of bulb tees, 9 spans of steel girders, and 2 of those spans had curvature to them. So we went through every possible aspect. You know, I wanted to do a county bridge, but this is what Scan Skill Wash gave me. So it was like, okay, here we go. We're going in the gauntlet, and we came out shining. It's just that the pandemic hit us on the backside. So the swivel lift right here is very important because we don't want any prying action to be put on those inserts. So this is an absolute with handling the actual panels. Whether you're at the precaster or in the field, you always want to be using this swivel lift, which basically has a pin right here and takes that prying action away virtually. You'll see later, we'll go through, you see there's three rows of inserts here. You know, in this photo, you can see we're kind of showing you how they're being used. And if you notice, all the panels, in order to get the production rates that we claim and that are easy, is 1 foot per linear foot. You're installing this per minute. I mean, 1 foot per minute. I mean, and you start comparing that to the antiquated way, and the other fact is set them and forget them. You're not coming back to strip these out, and everything's done topside. So this is a no-brainer. It's just that I'm not a salesman, I'm an engineer, I'm not a politician, you know, I'm a veteran. So, you know, I really need help to get this out to the masses, because it really is a great idea. Good job, Gary. But let's see here. This is showing a shear stud just shot on the beams. So, you know, you're the same guys out there shooting your shear studs, just throws in a different head and they're shooting these thread studs on. And if you want, out on LaGuardia, WSP was doing the review, they allowed them to count it in their stud count because they were 7/8 diameter, as long as they had a nut on the top and they were up in, if they wanted to extend them up in, I think we had somebody else 2 inches into the slab. And I'm going to show you a couple lessons learned out there. We can
Place it back here. What's it? Place the clicker here. If you go.
I got it.
Okay.
Yep. So in here, there's a splice plate that we have to negotiate over. So when we were first early prototypes, we haunched this section, but that precasters didn't like it. They need a separate form. So what we ended up doing was just sticking the slab. And so you just get a thickened panel there, and that notch becomes a little deeper to accept the additional depth of the splice plate. You know, problem solved, fast, easy. Another area was where they have the straps for the SIPs. They like to hook it around the flange. We wouldn't let them do that. We told them, no, we got to be bearing directly on that flange. And what I dubbed this as a line load, because I did testing. That was my biggest concern when I first came up with the idea. So I went to Home Depot, got a bag of 5,000 sack 6-inch samples, and started just putting my son's weight set on it and as much weight as I could. And I couldn't get the thing to break. I'm like, wait, conical failure, this tensions, all my calcs say this should have failed a long time ago. So I'm kind of like scratching my head. There's a little bit of an interaction, some kind of equation going on there that avoided me. And I was very happy because I was like, man, if that's not the weak spot, then I think I'm onto something here. So, you know, I dug this a line load because what happened is I opened it, rather than a 90-degree, which it was in the very beginning, I opened it up to a little bit of a bird's beak. So you really have a pure bearing. It's almost like a splitting wedge, you would think, but it doesn't act that way. It finds itself very solidly, so you get full pure distribution along the entire length of the panel, which are now 5 feet standard because New York State DOT, they have control joints at 5 feet. Started out at 8, but we evolved into 5 feet, which is also very good for camber and also very good for when you're negotiating, you're chording a curve. It looks like it's actually curved, but it's not. So you got a bunch of 5-foot vectors. So this is our standard arrangement. Now, we did testing at Lehigh, and the testing was out to 39 inches soffit width. So that soffit width is not, I'm not saying overhang, I'm not saying from the center of the girder to the outside, I'm saying from the very edge of the form to the outside of our panel. We tested up to 39 inches very successfully, and we couldn't get full failures. Even after, I think we had over 6 factors of safety, it was up to 6, and it performed way better than we thought. You know, Lehigh was there. We have reports that we could share with anybody that wants them, and at their Atlas lab. There's a lot of notes up here that, you know, I'm not going to go over because I want to save a lot of time at the end for questions. This tends to be a very innovative new product, so I know I'm going to get a lot of questions at the end. I hope I get a lot of questions. But I do want to go over some of the advantages or some of the uses of these inserts. One thing is, we started out with plastic, we had zinc, and we ended up developing with our shore builder, our hardware partner, steel. And it wasn't the strength. It didn't have anything to do with the strength or performance. What it had to do with iron workers out in the field that just, you're gonna break it. And they're gonna cross thread the plastic, they're gonna cross thread the zinc, and these steels are just bulletproof. And that's what these panels are now, they're bulletproof. So there's a lot of conservative built into these panels for a number of reasons. One is the iron workers. The other thing is slip forming. Slip forming is really where this becomes huge savings. So any of these big design builds, there was a project down in Mobile, Alabama, 15,000 linear feet. They were gonna slip form it, and that was their biggest thing. Like, as soon as they knew they could slip form it, they were like, oh boy, and then that project got shelved. I don't, hopefully it comes back on, right down the middle of Mobile, Alabama. I don't know where it's at right now, but there's, like I said before, there's 3 rows of inserts. So the top inserts, you're using for your swivel lift to start up with. But once you pour the deck, I see these lower inserts, you got 4 inserts that get embedded into the deck. Once you pour the deck, these ones with the triangles are for that diagonal ties that I showed in, they can come out once the deck cures. So they don't have those diagonal ties in your way for any of your barrier steel anymore. And what you can use, and then what you'll do is you'll see, I'll show you in some of the photographs, you'll see the anchors that we're using. Basically all those, at the very end, everything's filled with anchors. But you're utilizing these things for whatever you can. And you can put in other inserts based on the contractor's means and methods. So some bridges, they might need to transverse around the bidwell. A lot of staging now, you're doing everything in stages, right? So you really don't need that in most cases, but on smaller bridges, if they're doing the whole span, that middle one right there, for instance, we keep that there for a pick bracket, so that if the contractor needs a transverse, he can. But he doesn't have to go to the outside. We don't want him on the outside. That loads a little, you get a little bit more eccentricity. He doesn't need to be on the outside now. There's no bug holes, nothing to rub out, no work out there anymore. So, 10 years is a long time for lesson learned, and these are the kind of stuff that we've learned, and it's ready to go. Oh yeah, so the other thing is, once you pour the deck down here and you lose your 8 inches, which this is, the height here is for an OSHA height, so once the panel goes in, you don't have to be using your yo-yos. Out in LaGuardia, Lathers were coming up to me and like, oh man, this is great, we're not tripping over yo-yos, we get to take more breaks. I'm going, what do you mean you get to take more breaks? Oh, we're moving twice as fast as we usually do. I go, so why are you taking, well, we don't want them to know, the supervisors. So I'm like, oh. Same thing happened with the guys setting the panels. I'm taking videos, I'm like, guys, speed it up. Why? I go, you can go faster, right? Yeah, but we're just doing a span a day. That's it. That's all they're expecting. I go, well, no, we could do 2, maybe 3. I'm like, oh, guys, could you please go faster? No, they were just, who are you? But so unions are kind of tough when it comes to really getting the go. So it's new. It's going to take a little while before people really start, I guess, getting up to the production rates where they should be. These inserts are steel. They're also located behind the horizontal bar. So your inserts are never gonna be a problem. There's never any concern with any type of conical barrel on you, because you would have to literally rip the entire wire mesh reinforcement out to do so. And these upper inserts, like I was gonna say before, you had the OSHA height before they pour the deck, but once they pour the deck, you'll lose your now your railings down to here. So our hardware shore built, they have basically these rails that just a simple angle with a bar across the top that gets you back to your OSHA height that you can use these in until you get your barrier steel up, and then you can take everything out. So you do get faster production with your other trades, is what I'm trying to say. This is the latest and greatest. Keep it simple, stupid. We had several different iterations of hardware design. This is basically a studge. The stud's just shot on the beam. It could be a rebar too. We have a rebar clamp that does basically the same thing, and your secondary and primary both come into the same location. So this does a bunch of stuff as far as construction tolerances also, because you have a lot of leeway of which way you can take those loops and turn them, and nothing has to be perfect. There's a lot of construction tolerances in this product. Ton of benefits, 1 foot per linear. I think that's the one that just is like, what? Because you just, it's a no-brainer. I just can't emphasize how quick and easy these things go in. Architects love them because they give them any kind of finish they want. You can put any kind of form liners inside the forms to get whatever you want, and it just becomes pretty obvious that these are gonna be, you know, the way to do bridge overhangs, you know, in the next 10 years, if not sooner, hopefully sooner.
5 minutes,
Finishing, bunch of different ways to finish, but this guy right here, he basically taught us all the proper way to finish. We finish from the front side. As that auger rebounds off the rail, he basically reaches in there and he makes it look like glass. I showed up one day when they were doing some of the early pours, and I was standing in the back, and everything was finished between the rail and the barrier, and I'm like, how are they doing that? I'm watching the guy on the work bridge. This guy here was just doing the spray, the curing compound. He wasn't reaching down. He doesn't have a trowel in his hand. This guy was the guy doing all the trowel work, and it was very serendipitous. No extra guy on the crew, and you know, that's a lot of times the contractor would hit me with that question, like, well, how are we supposed to finish between here and there? Because they like to put the rail out on the actual bridge brackets, which would put them out on our panels, and we don't want them on the panels because it will generate stress cracks with that kind of weight. It's too hard, and everything kind of grows, and it's no good also from rebound, because as that bidwell goes across, it deflects, and you get this washboard effect. I was just talking to one of my fellow speakers, and they said, yeah, we had a diamond grind. I go, I've had a diamond grind a couple different times, and you know, that's, you know, you start seeing bridge brackets like 1 foot apart, that's why, because they can't afford that deflection. You know, comparing it, I don't think there is any comparison. This is, you know, it really does become a very aesthetic. This is the frontage road, so this is the front of the terminal, the central terminal. This is, you know, this is where they want the pristine. This, however, they put water in the mix, they over rubbed it, scaled it. That's now falling apart and delaminating already, and this project's not even a year old. So from a service life, this makes a lot of sense from the owner, much less permeable, all the shop control, and it really does look beautiful at the end of the day. A couple different shots, you can really see, you know, the studs that we're talking about, some of the stuff up close. I'm gonna run through because I'm not gonna have much time for questions, but there's the slip form. We had to do a full-scale slip form demo for Skanska Walsh, who was the contractor, because they intended to do slip form. That's where they had the huge savings. But they got landlocked out because they didn't have any bridges built on either side of this structure yet. So they looked at it and they said, you know what? This thing's so fast, we're gonna do it conventional anyway. You know, they were thinking about lifting the slip form up, and they said, you know what? We can do it just as fast, conventional almost. There's really not a crazy savings difference than what they thought. They were comparing the slip form to the antiquated old way bridge brackets, huge savings, a huge difference. But not so much once they got into it and they realized, like, wow, this is faster than we thought. Another thing, here's the Shore Build has designed some forming systems. This is if you're not doing slip form, you know, standard conventional timber, or like a barrier that just kind of flips over. This one's very fast. This one's really makes it fast. This one right here. There's the finished product, and I'd like to open it up to questions.
I got a ton of questions, but I still don't get it. But one thing is, you got all those little diagonal braces in there. Where do
They come
go?
out.
Well, if they come out, how does the thing hold itself up?
Well, here's the first stage, right? You're putting the panel in. Second stage, you pour the deck. Once you pour the deck and it cures, those lower inserts, it's secure. You can pour up against it. So those diagonals come out in that second stage as soon as the deck cures.
No question. So the traditional brackets put torsion on the beam a little bit.
Right?
Yours puts it all right on the top flange. That's a whole different stress distribution.
But it distributes it. So we've only had one job where we had an issue with the top flange. That was at very tip of Long Island because of a flange tilt. And that was a bridge that was designed with the fascia girders based on actual loading, you know, and since they don't feel all the live load, back in those days, they designed them differently. But you found out over the years that those are the girders that deteriorate the most, so let's just make them the same size of the governing girders. That's pretty much what we see everywhere, and we haven't had any issues with that other than that one instant. And that was the first time I saw one of those bridges and heard that story. So it was kind of enlightening.
Any crash testing has to be done in the system?
Say again?
Crash testing for that?
Well, New York State DOT, they have one caveat. They treat it as means and methods. They want engineered submittal just like you would for a bridge bracket submittal. And they want you to hold the inside of our panel to the outside of the proposed form line. So when you look at this barrier here, this is actually all design barrier. Everything inside our form is per the proposed drawings.
How much is the load on the, per foot, extra load? Could this load become permanent load? What is the load?
The panels range about from 1,000 to 1,500 pounds total, and they're 5 feet, so 200 to 250, something like that.
So that is additional dead load in the design?
Yeah, you do, but not necessarily, because when you start looking at the camber, it's incidental almost, but they did include it in their design on the LaGuardia.
You said 39 inches from the soffit. Is that like a maximum, or?
That's what we're tested up to, and I wouldn't go beyond that, because then maybe you start getting into some flange tilt issues and also some stress cracking and stuff, and we just don't recommend it past the testing that we've done today. Even though I've doubled the reinforcement from the testing, and that's the reason we doubled the reinforcement is because of slip forming. Slip forming can create reverse stresses and stuff that we're not anticipating in all our engineering and design. So we, again, belts and suspenders, it's double the reinforcement. That it's a 4x4 wire mesh is what was tested and what was used out here. But working with the slip formers and stuff, and just erring on the side of caution and looking at cost, it doesn't really cost much more to add that little bit and increase concrete strength and stuff. Everything's the material, technology is getting better and better and better. So we put twice. Now it's 2x4 wire mesh.
But if you had like a smaller overhang, you could reduce the.
We've had actually PennDOT. We designed 2 bridges for the rapid bridge replacement. For one of them had 0 soffit. It was just straight up and down. Now with those, you can't. You don't use the hardware like this. You have an insert straight in here that you're using. So it's just a little bit different. Once you get over 6 inches, I think, or 12 inches. There are 3 types of panel, type 1, 2, and 3, and it's all based off soffit wood. Any more?
Yeah, from a contractor's perspective, a couple of questions. I see that you're running the screed rail for the finishing machine on the girders on, presumably pipe sleeves for the yokes.
Yep.
It looks like from your pictures that you're just leaving those in.
They did that. In our mock-ups that we pulled them as we went with the work bridges. They left them in and just grouted them back on this job.
How do you pull the rail because you have no walkway?
No, they don't put. They're just pulling the everything but the rail. And then they pull that out later and grout it back.
Yeah, because with conventional overhang, what you're losing with this system is a walkway.
Well, no. What I didn't show you is the pick bracket. So the pick bracket does. You have 20-foot picks, and you have 1 bracket in the center of each panel. So you do have a way of getting back to pull them out if you want.
So you run aluminum scaffold picks on the inside.
Yeah, just 1-footers. Just fit right inside and just run along the inside.
The whole length of the bridge.
If you want to do what you want to do, yes.
Because I'm picturing that if you have a work bridge for the burlap crew, and you run out of burlap, how do you get the burlap out there? You don't have a walkway.
Well,
Crane access everywhere.
Well, like I said, when you have the stage construction, you have that access on that other side usually.
Yeah.
But if you don't, if you're doing a full width county bridge, let's say, then you need to put your picks, like you said, from the beginning to end. You're going to want to pick it out so that you can transverse your bid well. That's the testing from Lehigh. We could not get it to fail. This is filled with Black Beauty entirely, and we could not get it to fail. Even though calcs and everything said it would, we couldn't get it to fail.
Okay, well, thanks everyone. We'll have to cut it off there.
All right.
Thank you,